All right, as promised, we are splitting up section 6.1 into a few parts. So today is the first part, part A. We are going to talk about products of powers. So we are going to multiply monomials using the product of power rule. Just as a review, a monomial means it is one term. If you weren't sure what monomials were, it means there's just one term to them. Anybody need more time with the objective on the screen?
Yeah.
Okay. For those warm-ups, this is what we talked about yesterday a little bit. If we are going to simplify these, we have to use our order of operations. By our order of operations, what should we be focused on first with number one? Okay, we gotta simplify those exponents. So 2 to the third power. What would that simplify to be?
2 times 2.
Yes, it is 2 times 2 times 2, which equals 8. Multiplied by 2 to the fifth. 32. So 2 times 2 times 2 times 2 times 2 is 32. And then we have to multiply those together, which ends up being 256.
Wait, so
Yes.
you did the so on 2 to the third power, you just did 2 times 2 times 2, and then you just put the answer right here, and then okay.
Yep. All right, on number 2, the first power we have is 3 squared. What is that?
3, 9.
3 times 3 is 9. And then we have
8.
2 cubed, which again equals 8. So when we multiply them together, we get 2. Okay, that's a short review of what we talked about a little bit yesterday. Questions, concerns, need more time with the warm-ups? Okay. All right, in our notes for today, there's really just one rule that we're focusing on. To multiply 2 powers having the same base, you add the exponents. Okay, you're multiplying powers, but you end up adding the exponents. So when it says for all positive integers m and n, if you are taking a to the m power times a to the n power, notice our bases are the same, they're both a's, then we are going to keep that same base of a, and we are going to add the exponents m plus n. Now, when we do this throughout the examples, usually our exponents will actually be numbers, so we would actually add them together. Your bases could be a variable like a, or your base could be a number. Anybody need more time on this slide? Okay. Then we'll jump into our examples. On number 1, we are multiplying y to the 4th times y squared. What is our base here?
Y.
Y is the base. We're going to keep that same base of y. And we are going to add the exponents. What are the exponents?
Times 4. No, times what?
Okay, the exponents are 4 and 2. That's what's getting added. So we end up with y to the 6th power.
Let's do it.
Now, I will not always require you to show me this middle step here. Okay, you need to learn what this rule is and be able to just do that mentally. But that's how we're coming up with the 6. We're adding those exponents. Now, if you need proof about why it works that way, y to the 4th means I have how many y's multiplied together? 4 of them. So y times y times y times y. Y squared means I have how many y's?
2.
2. Y times y. So if I were to expand it all out and count them all up, how many y's do I have total? 6 of them. That's why this is the rule. We add the exponents. Keep the same base, add the exponents. Number 2 works just a little bit differently because we have coefficients out in front. So what do you think I'm doing with the 4 and the 5? We're multiplying them. Remember, parentheses tell us to multiply as well. So 4 times 5 is 20. We still have n cubed times n squared. So what? We add them, which gives us 5. So we would have 3 plus 2, 20n to the 5th. Questions about number 2? Okay. On number 3, how many different bases do we have? 2 different bases. What's one of my bases? A. Okay. Ooh. So one of my bases is A. What's the other base? B. What is the exponent on A from the first set of parentheses? A 1. Remember, if it's not written there, you have to know that really it's to the first power. So it does have an exponent of 1. Plus, what's the other exponent on an A? 2 from back here. So we're going to take 1 plus 2 for that one. B, what's the first exponent? The 2 plus the other exponent is 1. So in the end, we end up with A to the 3rd power, B to the 3rd power. Okay, we're going through some of these rather slowly, a little step at a time, just so that we can make sure we're all on the same page. Questions about 1, 2, or 3? Need more time with this slide on the board. Okay. On example 4, the 2 is getting multiplied by the 5. 2 times 5 is 10. What is S times S? S squared. So they both have an exponent of 1. 1 plus 1 is 2. On number 5, the coefficients get multiplied together. Okay, so 5 times 3 gives me 15. X to what power? The 7th. Good. We got to take the 5 plus the 2. Y to the 3rd power. Because this y back here has a 1 on it. This one's got a 2. Questions? Concerns? Need more time? Okay. All right, this note is found on the back page. It will also be on the next slide as well. But what is different about this problem? We have a negative involved somewhere. What else? Sort of. Why do you say binomial?
Because there's
Two what?
two sets.
Good. We've got this plus sign. Ooh, sorry. Hit the button. Okay. We've got this plus sign in the middle that breaks our problem up into two pieces. Okay, so we can multiply this side together. We can multiply that side together, but they are broken up by that plus sign. So let's focus on just the left side first. So we're just going to do this left piece first. The 2 gets multiplied by, what do we get? Okay, we get a to the,
-12
a to what power?
to the
Fifth power, b to the
4th.
fourth power. Then there's that plus sign. On the other side, this 2 back here is getting multiplied by what?
Nothing, so it stays.
No, it just says 2. What? 1?
It's not enough. It is a 1. Okay, technically we're multiplying it by a 1. So yes, it does stay a 2. If we were multiplying it by nothing or 0, then it would change. So we've got 2a to the 5th, b to the 4th. Okay, if you need to, go through on your plain variables and add in those little exponents of 1. What do you notice about these two sides?
They're able to be added together
Why?
due to their letters.
What about their letters?
They're the same.
They have the same letters with the same
Exponent.
exponents. So yes, they can be combined. You have to have all letters match up with the same exponents in order for them to be combined. And when we do that, we have to just add the coefficients. So that means I'm taking -12 plus 2. What's okay? Our exponents back here on A and B do not change. That's what this note at the top is about. We're only adding coefficients together, meaning the numbers out in front. We're not going to change the exponents when we combine like terms. That is an issue that we ran into back when we reviewed earlier in the year. Anybody need more time on 6 before we move on? Okay. On number 7, are we going to have to combine, like add or subtract, any of our coefficients or terms? No. There's only one operation happening, and it is multiplication. Okay, we don't have any addition or subtraction signs happening. This is a -7, but because it's in parentheses, we know that we're still just multiplying. So as far as coefficients go, those all get multiplied together. So we could do that separately. We could take 4 times 1/4 times 7. -7, sorry. If we do that, 4 times 1/4 times -7, Deontay,
-7.
is -7.
7.
4 times 1/4, those reduce to a 1. So we end up with 1 times -7. Or if you have a calculator, it'll do the heavy lifting for you. So this is going to be -7m to the y6.
Because 3 plus 2 is 5, and then you add a 1 to the other.
Good. 3 plus 2 plus 1 gives us 6.
Oh.
Questions about example 7? Okay. On example 8. If you wanted to, you could do some reducing before you get started. Or we can just multiply straight across the top, straight across the bottom. Let's go ahead and just multiply, and we'll do our reducing at the end. So if we multiply across the top, the 20 is going to get multiplied by 20 times 12 is
240.
Okay, we multiply the same bases together. So x squared times x cubed is x to the 5th power. And then we have y times y to the 5th, which would be y to the 6th power. In our denominator, what do we have? 15. Before we reduce, do we have questions about how we got there? Okay, what can we reduce?
240 divided by 15, that's 16.
All right, so we end up with 16 x to the 5th, y to the 6th. Can I take this and make this xy to the 11th? No, because x and y are not the same kind of letter, variable, base. If you don't have the same base, then there's nothing to do with them. Only combine their exponents if you're multiplying the same base or the same variable. I feel very confident that at least 25% of you have a good idea of what's going on. Some of you have been rather quiet, and so I'm unsure of if you're just being quiet or if you have no idea what's going on and you're letting your other confident classmates dominate the conversation. So, do we have any questions at this point? We're sure? Okay. Well, let's move on. On number 9 and number 10.
I was gonna ask, why it only shows it as this s to the s power, and on yours it says s to the 2nd power?
We all get it edited? Okay. If we take 6s to the 5th times 2s squared, what do we get?
Oh, wait, what? 12.
12. S to the
Wait, S?
to the 7th. I heard some people saying it. Okay, 5 plus 2 would give us 7. Minus, then we have to multiply these two in the back together. What would we get? 12. S to the 7th power. When we can add or subtract terms because they are like, meaning same letter or letters with the same exponents, we only add or subtract their coefficients. So in this case, we would take 12 minus 12. 12 minus 12 is 0. You could put 0 s to the 7th, but 0 times anything is really just, whoa. 0. 0 times anything is just 0. Okay, it was like you were given 12 sandwiches and then somebody took 12 sandwiches away. You got nothing. Questions on 9 before we do 10? Okay? On number 10, again, make sure you're splitting your problem up based on where the addition or subtraction sign is. So we've got this first part of it is 4a squared b squared times 2a to the 4th b to the 5th. So 4 gets multiplied by, we get A to the
6,
B to the
7.
questions about where those 6 and 7 came from? Okay, minus in the back, the 3 is getting multiplied by
1.
a 1. 3 times 1 is,
That is 3.
so minus 3, A to the
6.
B to the,
7.
okay, so 1 on the A plus 5 gave us a 6. 3 on the B plus 4 on the B gave us a 7. When we combine these, what do we get?
Negative 24.
Disagree. What operation are we doing now? Somebody said it softly. Subtraction. Now we actually have to subtract because these are like terms.
So it's 5A
I think it's 176.
to
Good. 5A to the 6, B to the 7. We just take 8 minus 3. That gives us the 5. The variables keep their same exponents. Questions about 9 or 10?